going to explain how to do problems like questions number 19 and 20 on the review guide. I'm not going to use the exact ones, I'll use different ones so you can use those as some you can try for yourself. Suppose that we had three 60 degrees. Now here we have a polar coordinate. Remember, polar coordinates come in the form of r and theta. The radius and the theta, remember if you graph that, if I were to draw that, I'm going to turn to 60 degrees. Right, so that's 60, and then we're going to take the radius and we're going to go out 3 steps, right? So it would be 1, 2, 3. In a polar graph, you would see these represented by circles on the graph. We're just going to kind of estimate those as 1, 2, 3. So wherever you'd find that third circle, that's exactly where my point would be. So this is point A, then that's exactly how you get it. So first things first is knowing how to graph the point. There are 3 other representations of this same exact point. What I mean by that is there are 4 ways to describe a point using r and theta. A bit of information about theta, right? Theta, if you go around this direction, you generate positive angles. If you go around this direction, you're going to have negative angle measures, okay? About r, if I turn to an angle, let's say I go 35 degrees, right? If I walk out towards a positive r would go towards the angle, right? A negative r would back up and go in the opposite direction, right? So positive r goes forwards towards the angle, and negative r would be like backing up. For example, if I had negative 3 and let's say 135 degrees, kind of what we have kind of shown here. So if I turned my direction towards 135, but I'm going to back up 1, 2, 3 steps, my point would exist in the 4th quadrant because I'm going to be going in the opposite direction of the angle that I'm going to turn, right? So those are the bases for understanding what we're about to say, okay? First things first, I know that if I look at an angle measure right here, that as we said earlier, this is 60 degrees. And I walked out 3 steps to get to that point, right there. I can go in the opposite direction. I can go down in another direction and go just the opposite way, and I can go to here. That's going to also, and I'm still going to go out, I'm still going to go that far to go to my positive 3. So the radius here is exactly the same. It's going to be 3, but what angle did we turn? Well, we were almost at negative 360. I almost turned a full circle, but I was 60 degrees short of that, really. So what we did here was we said, I'm going to take that 60, and to get this angle, I'm just going to subtract 360 degrees. Just go full way around a circle. And so we would end up with negative 300 degrees. Let's put that in red. All right, so we end up with negative 300 degrees. If I turned negative 300 and walked forward 3 steps, I'm going to end up with that point. Okay, so that's the first one. The other one is I can turn to 2 other angles, but I need them to be down here, right? Let's put that in a different color. I'm going to turn and I'm going to get an angle measure that ends up going down here, and I'm going to have a negative 3 radius. In that case, when I turn to this angle at the bottom, this angle down here, if I turn here or go around this way, I can back 1, 2, 3 steps going backwards using a negative radius, and I could get to this point as well. The question is, what is this angle? And what is the angle above going positively? The clue that we have is the first things first, that you will always generate what we call vertical angles. So we know the angle down here is also 60. From what we know about our unit circle, we know that the horizontal is 180. If I add the 180 plus the 60, we know that this is going to be 240 degrees. So really, what I did was I said, well, let's take that 60, and if we add 180 to it, I'm going to get the 240 degrees. Okay, now if I turn to 240, if we take that visually, we say I'm going to turn all the way to 240, and we're going to back up 1, 2, 3 steps, I get to this point. I want to go around this way. If this is this, if I almost get to negative 180 going in a negative direction, but I'm 60 degrees short of that, we end up getting another angle, right? This direction right here would be negative 120. right? So end up here, negative 120, and I back up in the same fashion, I'm going to get to the same position as we had earlier. And that's going to get me all 4 representative angles and directions. Okay, so that allows me to get to 4 different directions. Let me put this other, we had this one, and then these 2. That's 4 angles. Notice the pattern here. I'm always going to have 2 positive radii and then 2 negative radii. I also have 2 negative angles and 2 positive angles. Those are also true as well. Okay, if that was confusing, do it again. Practice this. Let me add one more thing. If you like formulas, what we did here was in this case, I always go from the 3rd angle to the 4th angle by just adding 360 degrees to it. No, back, almost. I subtracted 360. A good rule of thumb is that, do I add 360? Do I subtract 360? Do I add 180? In this example, if you start off with a positive angle, like this one, I'm going to subtract 360. If you get to an angle that is outside of 360 to negative 360, you went the wrong direction. Let's do another example, but this time let's do it in radians because you have another example in radians. What if we had, let's just say negative 2 and 3 pi over 4. And this is the coordinate. I'm going to draw this first. If you don't remember, we can convert radians to degrees. Now, let's be honest. Could you just convert it to degrees and do the whole thing and then convert all your degrees back into radians? Absolutely. That is a definite possibility. That's a little bit more work. If that's your only connection and you totally get that, then maybe that's where you go. 3 times 180 over 4 is going to be 135 degrees. So if I draw that angle in right here, we know that if we go out like that, that's 135. However, the radius is negative here, so I'm going to have to back up away from that 1, 2 spaces. So we're going to end up with a coordinate, or point, in the 4th quadrant, right? And so we know that we can do the forward angle, and there's also a reverse angle. I can also go down here and go back to that angle position, and that's going to be my 2nd angle. And before I get there, I want to set something up. I'm going to go ahead and get 50% of my credit without even trying. If there are 6 blanks that I'm trying to find, I'm just filling in 3 of them. And let's be honest, I didn't even need to think about that. There's 2 positive radii and there are 2 negative radii. Done. End of story. At least I got half credit, even if I can't do anything else. Okay? Now, to go down here, I'm going to go backwards and go to the negative direction. Now, I have a positive angle. I'm going to keep this in radians. So if you're doing this in degrees, this isn't for you. You can go back to the first example to explore that. I'm going to add, I'm already positive, so I'm going to subtract 2 pi. However, I have fourths, right? So I'm going to multiply the bottom by 4 and the top by 4, and we're going to get 8 pi over 4 as a common denominator, right? So 3 minus 8 is negative 5 pi over 4. So that is my next angle, negative 5 pi over 4. Right, if you think about it, this is just pi, and this is pi over 4. That's 45-degree reference angle. We need that from the beginning. I can just add the 4/4 plus the 1/4 to get that negative 5 pi over 4, right? So here we subtracted 2 pi to get to the next one. If I want to go back to this one, I want to turn positive. So I need to turn, if I look at the angle, I want to get down here now. I want to start here at the traditional place we start, the positive x-axis. I'm going to go down 1. I need that angle measure. I need all the way around to get this angle because I want to go forwards out. So I need to get this angle measure. Well, we already have a clue. We know that this is pi over 4 because we know we have vertical angles. We already knew the other side. So this is going to be, now that's going in a negative direction. So that's negative pi over 4. If I go all the way around again, back over like this, I'm like adding 360, right? So negative pi over 4 plus 360. But we're in radians, so I'm really not adding 360. I'm adding 2 pi again. We already wrote that. So I'm going to write 8 pi over 4 again. That's going to give me a positive 7 pi over 4. So this is going to be 7 pi over 4 here. And these are the 4 different ways, whether you're using radians or degrees, you can get 4 different descriptions, right? These 4 here, or if you're going back to the degree, you can see that happen up top as well. Right? If you have any questions, definitely give this a shot. I'm a very visual learner. For me, drawing this out with the different degrees here or here makes it solid for me. Some people like the plus 360, minus 360, or the plus 180, right? If we kind of fill that part in, for those of you that like that part, if I can get this to work for me. If we come back here, we're doing radian measures. So if I come back to this one, to get down here, the one I left out, I did it, but I added 2 pi again. And that allows me to get this one, right? To get the second one, we basically subtracted, if we were at 3 pi over 4, I just subtracted pi to get the other one, okay? I don't typically follow that pattern because it's positive, it's negative, sometimes it depends. And actually we added pi to that problem, right? I like the visual. You attach what you got, what you think works for you. And if you have questions, rewatch it. If you have other questions beyond that, send me an email and we'll talk about it later.